Hello and welcome back to another day of leaf coding where we play with Wormies, and let's jump right into it. If you're new to the show, we're doing leaf coding. Leaf coding is my language, and I'm just going to adjust the window size here for a second so we can see what's... Oh, I don't like these things sometimes. You know, KDE has this weird idea of vertical and horizontal maximization, and you can't just change it once one's set. Okay, so here we are. We're doing a game. It's in my language. My language is called Leaf. The game is very simple, of course, but, you know, we don't have a language that has a standard library. We're virtually missing everything still. Last time we built just these simple graphics using GL and STL, and we loaded the text, so we've come a long way, actually, and I'm happy with the way that looks. And today we're going to do is, because the graphics are really blocky, I just want to test another aspect of GL. Let's actually get some of the graphics, at least exploring that a bit more. And then maybe we'll make a dot move around the screen so we have two targets. And if we have time, maybe a simple menu, because right now when you die, that's it, game's over. The only way to restart is to actually close the thing and run it again. But we're coming a long way, and if you have any questions in your show, just let me know. There's a lot of stuff here. And again, it's written in Leaf, so if you're unfamiliar with this language, don't be surprised. It's language, and this purpose of the show is to work through the compiler. Right now in the compiler, I'm working on the edA-qa to call weird functions that can pass and return structures with substructures and pack structures. Very odd use cases, but something a language should probably support. So this game class, this is the basic game. With the overall code is split into a couple of different versions. We have the renderer, so we have the renderer. The renderer does nothing for the game renderer. This is, oh, and it's not keeping my, I have a theme. Let's just use apply, there we go. And so I'm going to use a larger theme so you guys can see it a bit better. The renderer takes care of displaying stuff on the screen. That's very clear. The game takes care of dealing, tracking the game without doing anything. Then we have a main function, which is all the SDL setup and keyboard state setup. So this handles the keys. And very straightforward, and takes care of the ticking and what's not, and the basic rendering, the clearing the color, clearing, and then rendering, calling the renderer. This main function won't change very much until we add new hardware support, and that's going to be the game controller at some point, or more keys, or whatever we do. Okay. Now we have the renderer is what we want to work on first. The renderer, when it draws, it has two components. It has the game renderer and the UI renderer. Now they're combined together right now, and I actually think we should make a separate renderer called the game render, the game field renderer. It's called the game field renderer, and that's simply going to become this one, the game field renderer. Because then we're going to make a second service called game renderer, just combines the two. Because right now that one kind of does both. And we're going to go field, game field renderer. Now, if you're wondering, I have this one defined before this one's defined. In Leaf, the order of definitions is pretty much irrelevant in the namespace scope. You can copy and move stuff all over different files. You don't need to include files or anything. Just put them wherever you want, and it'll get the ordering correct for you. Alright, and so now we need to render. This is the function here. This is just going to become render. And we move this one out. And I actually put this at the top of the file because it's the most important part of the file. This is the high-level render. I can put it right at the top, and everything else is details to this. And this is the one that would be public. We don't have public and private yet, but this was the one it would be. And so we also can render the field. Field.render state. Okay, if I did this right, I should be able to run it again without a problem. Alright, so now do you notice the UI is on top? To show what this helps us do is we could simply put the UI on the bottom now if we wanted, render it first, and then we would render on top instead. But that also affects the scoring, so we actually want to keep the UI on top for now because it actually makes sense for games. and then we'd exclude the array later. We just have this title right here for now, so we'll get verified that the text actually works. It will actually go away later. Okay. So let's make those little boxes on the screen somewhat round. And we'll do this on the head of it. So we have a push box function. Let's create another one called push body segment. And this is where we're going to push it to this I point. This is an integer point. And we're going to give it a color again. I don't know why we pass it as a segment color. We probably don't need that for the segment anymore because it's not generic. And we're going to, always we call it push box, we're going to call it push body segment, except for the dot. The dot's still going to be... Right, and so we still have push box for the state, and we'll push something else for that. And push body segment is going to be the same thing again. We have all these positions, and we're just going to create triangles out of them. Now we have to track where the current vertex is, because we're going to have to push the index data again. Now let's start with a circle. A circle is relatively easy to produce, and it's relatively easy to calculate then, because then what we can do, we're going to push these all relative then. And so we're going to say what the base is. The base is going to be base point equals... Do I actually have a point class or just an I point? I'm not even sure. I don't even know where I've defined I point, to be honest. That's kind of silly. Probably in the game itself. Game has an I point. Good. What we're going to do is equal. I guess we have a float too, so maybe we should just use the float 2. That makes more sense. Base point is a GL float 2 because we actually have to pass it to it, and this is going to be, it's going to be a point of, what do we say in the other one? There it is. Going to convert to a float, a GL float. And the reason we have to convert is because Leaf doesn't allow you to have conversions that lose data by default. And converting an integer to a float is a lossy conversion if they're the same size. So you have to explicitly say, hey, look, I'm willing to deal with a lossy conversion, and the GL float here is explicit. Convert it lossily to float explicitly. Otherwise, a lossy, just a normal lossy like up here, is another option that says convert to whatever type you want, which could be dangerous, but if you know, you have to give the programmer some reasonable sense of control. And position.x plus 0.5, and that's the base point. So we've sized our screen to actually have the size of the grid. So we should be okay here. And I was thinking we do it, but this simplifies as well. Glossy position y. So we're going to create a circle around this. So we put the position, the base position, to the center of the dot we want to draw. And we're going to push a dot there right away too. Vertex data.push base point. And we're also going to push the color there because they all need to have the color. Vertex color push color. We're not going to push, and this is where the VDP is. VDP 0 is now VDP 0 base point. We're going to push the areas around the circle first of all in increments, and then we're going to add the indices to create the triangles out of that. We're not going to make it a high precision circle, just something very basic. And how many steps do we want? We want to say var steps equals, how many steps do we want? And we can actually do this at floating point. And yeah, with floating point. I mean, and we have to divide it so that the things line up. You don't have to, but it's going to make sense. We want the actual segments on there. So we've divided into 8 segments. Let's just do that first of all. We have 8 segments. And then for step in 0 dot dot. Actually, sorry, this is step. I have so many different things, languages, I get confused. This is a range of steps. Now, I think I had a pi variable somewhere. I don't know where I put it. Like, there's part of the standard library we have pi. I think it's in math. We're going to find out right away. And let's see what happens if we do. So we're going to push the same vertex color again. That's the easy part. Push color. And then we're going to push the segment. And this is base point.x plus math.cosine. Oh, let's do the angle here first for our angle equals. And I think I have a pi. I don't remember. We're going to find out, though. We can add it if we're missing it. Math.pi is fairly common. Unicode pi is also going to work at some point, but I have to fix my parser as well. And this is actually 2 times pi times step divided by... Actually, this has to be... It can't be funny. Step divided by lossy steps. And that's the current angle, and then we do the cosine of the angle, and base point dot y plus the math of the sine of the angle. And close that off there. And let's just see if this compiles first. Rational literal CR range loss. All right, so I have a bit of an error here. Where did this one happen? Rational literal. Where did I do that? We're dealing with a different compiler. We don't have the errors yet, so we have this range loss, and we don't actually know where it is. There's a few places in the compiler still that don't produce the right output. All right, so it's within there somewhere. Can't be that, though. No. And... what part is causing it to fail? Let's just find out. This is why I try to compile multiple steps, just so if we have these errors. And it's also really trivial to compile. I mean, it compiles really fast. So it's right here is the error. Okay. And so step divided by steps. Well, this is also going to have to be a lossy float. We're going to convert this to a float as well. And we're actually just going to convert this to a normal float. Float. Whoops. Come on. Float. We're just going to force it to these floats. Logically, the compiler eventually should be able to figure out that this step, because it's in the range of steps, which is a constant, that you don't actually have to have a lossy conversion here. It knows from 0 to 8 that it can do that. So this is all float, 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 and that should get rid of that. Yeah, so we have that conversion. And to do missing one lossy float caused error without source. Okay, now we're going to push these back and make sure we do it. And this is going to have to be lossy now to a GL float, but we can simply do the whole thing because we know it's going to convert to the correct type here. Okay, now we have no worm now. He's invisible. And somehow I managed to eat that dot. Okay, so now we have to add it. We have all these dots. We have all these dots around the circle. And so now we have to push the index data. And for every step around the circle, we have one triangle. And that's what makes circles very easy to do for step. And we could actually do it part of this one here. But that's a bit weird, so let's just do a second one. Standard range 0, steps. Okay, so what do we want to do? We want to push, and VDP is the base, so we can always push that first. So we can always do index data.push VDP plus 0. I always put the plus 0 even though it seems weird because we're doing offsetting, and it's just coincidental as at 0. We want to very clearly see at 0. And this is starting at this one. And then what we want to do is we want to push the index data, push step, so VDP plus step. And now we want to push plus 1, except we have to make sure it's modulus correcti. VDP plus step plus 1. And there's a mod function, so mod step plus 1, steps. So the final one actually goes back to the first one. And at least we got an error there. right here we have an error, push. All right, we're going to have to convert these because these steps are in, step is in gluent. So again, there's integers here and there's integers, and lossy gluent, get size, lossy gluent, and maybe we should also make this gluent here. Oh, but then I have to convert step anyways. Let's just do it this way. Let's just convert it here. This should convert to a gluent, gluent. Or let's just do a glossy, glossy. I don't care what type it's converting to. It'll be fine. Alright, we're missing a dot somewhere. See, don't go far enough. But you can see we have it, and we're too big. And that's because we're supposed to be half the size. But we have something working, that's good enough. And this is going to have to be times 0.5 times 0.5 because we cover a whole area of 1 in the virtual grid, and math and cosine will produce an area of 2, or a space of 2. And we don't go far enough, we have 2 times pi. And we go up to steps. And if steps is 2, we're missing like 2 steps. This is the right size now. Why are we missing 2 steps now? You notice it also looks like he's going faster now, because when it's a block you can't quite tell. It now actually looks like he's going faster. 0 to steps. If we cut a circle into 2 steps, 1, 2. Well, let's put this up to 16. Do we still miss the same amount, or we're missing exactly 2? We're missing exactly 2, I think. It's getting rounder here. This doesn't make any sense. Why would we be missing 1? Any idea why we're missing 1? Vertex data, index data, that should all be fine. If we weren't getting the right length of the indexes, we wouldn't be producing the dots, so we know the index data as getting the right length. This produces 3 triangles, 1 for each step. We divide the circle in 2. Let's go with 4. What specifically, what are we missing with 4? We're missing 2 of the triangles. And that's a bit weird. Why are we missing 2 triangles? Let's figure out why we're missing 2 triangles. Putting a printout. This is an issue. We could put a print here somewhere, but that becomes like extreme. Let's do it. And I'm just going to print an empty line here. Or I'll put a dot in there. We're going to print out all the angles. Angle, space. Do another print line. These are just debugging. I don't have a proper debugging facility yet. And we can print steps. Equal. This is going to print out lots, of course. Okay. So steps equal 4. That's correct. The angle is 0, 1.5, 3, 4.5. That's all. That's the 4 dots of the thing. Steps equals 4, and step. Oh, we have to do VDP plus 1 plus this. Because the angles start after the base. So that makes more sense. This didn't help. This was really just, I didn't see anything from the printing. I just happened to see it at the same time. Alright, so now we have a triangle. So a triangle, at least we confirmed that we have the dots being drawn. But we wanted more of a circle. And these aren't anti-alias or anything. I don't care about that yet. That's something we can turn on later. I think it's a flag and stuff. We won't worry about that now. And we want to do 16 segments. Now, the issue here we have is that we don't really want a worm that's so segmented. These are like very clearly circles and these combined together. We'd rather have them combined so that, and it's much easier to see where he's going now though. We want to have them combined together so these look more like segments rather than actual separated pieces of a worm. Right, so how do we do that? So what we can do is we can take this angle here and we can take these sizes and we can apply maximums to them. We can make the circle a little bit oversized instead, so it cuts the corners. And that would actually be somewhere we can just adjust this here. And so a bit of an issue here that we have to convert. We have to clamp the range, I guess. Do I have a clamping function? Let's see if we have a clamping function. I don't think we do yet. We can make one here and leaf, Wormies, shares, standard library, math, basic math. We have no min or max. We have no clamping. So this is where I have the pi. You notice the pi is a very extreme literal. This converts to a lot of different types correctly. Literals are actually stored as rationals, and you hear my 2D is for that. So let's just stick the clamping function in here for now. Clamp. And I think I had this. I think this should work now. I think I got this working. We take any type, and A of t and B of t, and I don't remember if I got this. It's going to return a t. I know this is going to be min. It's going to be max t. And it's going to return t. Then we simply return a is less than minimum. Then we return minimum. Otherwise, a is greater than max. I don't know about the logical order. We can't actually do this. Sorry, we have to combine this in the line. A is greater than max. And I'll combine these together. Or a is greater than max, then we return max. Otherwise, we return a. And that should be a clamping function. If we get it wrong, we'll fix it later. And so now we want to do clamp. Whatever this is, and not times 0.5. Let's increase it to 0.5 and range it from 0 minus 5 to 0.5. And that's a decent clamp. And what I'm trying to do is make them a little bit bulbous so the segments stick together. And unexpected param type 23. Yeah, I can't remember. I thought I did this. Let me check the example code. I'm pretty sure I have this. I worked on this and I thought I got it working. Did I not finish it? It's possible. I just forgot about it. Unit tests, block. I'm just looking at test cases, parametric, function, and oh, I had to put a param. Yeah, that was a parsing issue. I need to actually put a param on this, because otherwise it's ambiguous parse, so we should be okay with that. And unable with ambiguous types for all statements. 6, 9, where's that? Weird. It's in a weird place then. And it's probably due to this clamping. If I just return A, what happens here? Alright, let's figure out where it's calling clamp. It may be an issue here about passing rationals to a parametric function because it doesn't know how to deal with that. Yeah. That's a bit weird, but it should know. Where was I? Something wrong there. Let's just check if this works first. If I explicitly say which version I'm using, if that resolves it. Alright, maybe that's the issue, because this is a float, and what if I just say float? Don't need a GL float. Alright, that might be the issue there. Okay, now he's way too big though. So there's a to-do here as well. To-do. Missing float on clamp. Had odd issue. It may have been an issue, but the error's invalid anyways. And so let's just say times 6 instead. Alright, that's getting closer to what I want. So now he's more stuck this way. He is kind of stuck together. More than he was before. So it's not a real circle, but he's rounded. And I think rounding is good enough. And without anti-aliasing, I don't know if we can shove his size any much closer together. We can make his segments more or less, but I think this does the segments well enough that we actually have segments here. But now I want to change something more. I want to get some more colors because we're using GL and flat coloring is not so much fun. The quickest thing we could do is obviously make the center color have more. We should be able to do this. Like, what if we push the center color just to be white? 1,1,1. Then you will have some shading there. So now the objects shine in the middle. And that's still not quite what we want, but it at least shows that we could actually do this. We got different things, and he's still a more interesting worm than before. But what we want to do is we'd rather use the GPU. We can actually put a normal on these things. Let's put a normal on the worm, and let's calculate on the side some fake shading for this worm. Alright. Let's undo that again. Just do that. So now what we want to do is we want to look at our Vertex Shader. If you're unfamiliar with GL, just ask questions, but I'm not great at GL either, so I just kind of have an idea. And these are called boxes, Fragment Shader, and Vertex Shader. And this is going to take another one now, an inVec3 vertex norm. And it's also going to do an outVec3 frag norm. Just do that. And frag norm simply equals vertex norm. And this is going to work much like the color now. We're going to have normals for all of these things. And in the fragment shader, we're going to have an inVec3 frag norm. Now we have to take care of doing all this stuff. Wherever we had the vertex color, we're going to have to do a vertex norm as well. Let's find the first one of these, game field renderer. Vertex norm equal GL buffer. This is also a buffer of float 3, GL float 3. GL array buffer Where's the next one? And we're going to attach it to the vNorm position. Guess we should do that as well. Var vNorm position. Vertex norm. And where does it come again? Same setup here. We could probably combine these together, but again, right at this moment, GL efficiency is the last thing on my mind. We're doing such simple graphics that our GPU is going to have no trouble regardless of how horribly inefficient we could possibly make this. They're used to rendering 3D games with probably near 1 billion triangles, and with skeletons, more vertex attributes, and all sorts of crap that we're just not going to get to. So our like few hundred triangles, doesn't matter how inefficiently we do it, we're probably going to be alright. Okay, so the box is going to do vertex norm.push, and we're just going to push a 1, 0, 0, 1. It's pointing towards the screen. So the Y direction is going to be facing towards us. We have to push 4 of them. In the body segment, we're going to do the same thing, push 1 norm pointing towards the screen. But then we're going to change it for each of these ones. For each of the data here, which way do we want to push it? We should probably normalize this, but let's just make it extreme. Let's make it pushing quite completely away. So we have a semicircle, and a semicircle then is going to be, this will be lossy GL float math.cosine angle. That's the x direction it's pointing. Let's do this in multiple lines so it's clearer. Lossy GL float. You could all do this all directly in float and GL float, and we could overload the library. But again, the standard library is not complete, and I want to just have simple functions first. And most calculations you do in the CPU, you want to have doubles anyways, like actual floats. These floats in Leaf default to a platform double precision, not a single precision, because usually single precision in normal programming is not what you want. Special case is graphics. So we have these norms, we push the norms, and we're going to have to push them here as well. Vertex norm, bind and push, and then we can use these norms. Let's first of all make a compile. And alright, so we have a small error here in the shader. We don't know which one, because I forgot to write out which one. Frag color, frag norm, and where is our vertex shader? Aha! It's supposed to be a 3. Alright, so getting the attribute of 1 failed. Vertex norm, frag norm, frag norm. Well, let's find out which one. Where did this fail? So probably in vertex norm, and we still have the error in Leaf. And I'll show you the issue that we can't properly report all of the errors yet. The error system is a structured exception system. It does allow you to have multiple tags. It's just we don't have an easy way to set them up yet. So there's not an easy way to set it up, and I should probably do it. So we're just going to cheat for now. Go into the lib and go into GL program. And there's a get attrib in here somewhere. And then just get a trib location. And we're just going to cheat for now to do, this should be part of the failure, not printed. We're going to cheat for now and just print out which one this was. Print line. Cannot yet attribute name. And I said, this should be part of the error information. This shouldn't be printed because you don't know where you're in. You shouldn't be printing it, but for us, we can. It should be part of this failure. The failure should also have the name in it so you can reference it. Vertex norm. So it can't find vertex norm. And I think I have a good idea why. I think I put these things in the wrong item. Game field. Norm? No. Vertex norm, boxes.frag, vertex norm, boxes.vert. Vertex norm is right there. I think we had this problem before. Oh yeah, no, we had this problem. This is something that's really difficult in GL to deal with, and I think it's because in the compiled program, it doesn't use that norm. Right? There's in the boxes frag, it doesn't use the norm yet, so it completely eliminates it. Let's see if there's a way to avoid this. GL. Oops, yeah. See, you can see it's a common error. But I want GL. No, I want GL. GL. Probably just say OpenGL. Tries GLSL. GLSL. That's what actually we're programming in GLSL. Alright, so there's no way to disable it, so we're just going to have to deal with it, and... Oops, I disabled you guys. So let's just use it. Let's just use it right away. Fragment color, and let's just do this times frag norm for now, just so we can see it. Vector size mismatch. Fine, fine, leave me alone. Frag norm. So they're black, of course. That's not unexpected here. So the issue is that it was. Let's just add it to it and see what we get. Because it's fully saturated at the percent, it's not going to make a big difference. So we have these frag norms, and what do we want to do is we want to have the intensity, and what light intensity we have. Where is the light coming from? Let's pretend if we do like vec4 light source or light direction equals vec4. Which light direction do we want to have? We'll just start with the obvious, that light's coming from the top. This is vec3. 3 light intensity. And if these are normalized, we're going to take the quick, cheap approach of light direction, comma, frag norm. And these have to have semicolons. And so frag 4 times light intensity. Let's see what that does. Uh-oh. Oh yeah, this is just a float. Well, that's dark. That's not so good. So why would that be? Why would that be? We have one in the middle. Dot product, shouldn't matter the direction of it. Do we have it facing the wrong direction? We should at least see the middle of the thing. No. It's been a while since I've done this, as you can tell. So if we're doing this right, and I think there's something wrong with the values, because the dot product, the point in the center should be at least 1, because it has the vertex of 1. We're doing a... Right, the vertex norms of the boxes, they're all with a z of 1, and that dot product with the light direction of 0, 0, 1 should give a value of 1, so it shouldn't have changed the intensity. And that's what's a little bit weird. 1 plus is that it's changing the intensity, and this is at least of the box here. This box should have the proper intensity. And it looks like we're probably passing the values wrong somehow. How do we easily test this? Well, let's do it this way. Let's take 0.01 times frag color, so we don't get rid of it, plus frag norm. This should give us some blue boxes. Alright, so frag norm is obviously not getting values. There's something wrong with frag norm. It's getting all zeros. We do it the same way as color. Color, norm, norm. So I think we've forgotten to enable something. That's probably it. I'm so convinced that let's just undo this a bit. And I think we've forgotten to enable something. Enable UI renderer. Aha, we have to enable the vertex attribute. So many things can go wrong in GL. It can be very hard to work with, and it can be very hard to debug, but just kind of stick with it. Alright, so now we have it. Whoa! Something's wrong there. What happened there? We're missing some norms somewhere. The box pushes 4 norms. That's correct, because it pushes 4 vertices. The body segment pushes 1 norm for each color. 1 norm pushes 2 norms. I think we're pushing enough norms. It thinks otherwise. Why would it think, oh no, this is, oh yeah. We have to clear the norms as well. Vertex norm.clear, otherwise we're just the wrong ones. Alright, so now we have a colored sort of dot. Obviously this is overdone, but it shows a little bit what we have. And now we want the light coming from a different direction, because that's something we can actually animate over time. And anybody remember how to normalize in GL? There's a function for it. Norm. Normalize? That seems like a reasonable function for normalize. Good. That makes it simple. Oops, got rid of that one. So the light direction, we're instead going to say which direction is it going or coming from. Let's say it's going off to the upper left instead. Or something like this. No, people like the other way. -1, -1, 0, and we're just going to normalize this. Right, and that actually shows that it is actually working. We have the normalization correct. It's still pretty intense though. It's still pretty dark, so we should probably have it come from more overhead. But we can also just give it a little bit to say that it has some latent color as well. So you can always just say, well, let's keep some latent color, plus dot times 0.7. Or you can actually do a lerp here. How does the lerp function work? Because that's the same thing. Lerp. Lerp. Oh, it's going to make me search on the zone. There's too much lerping. Oh, what was the lerp function? It's step or something? And what was OpenGL's OpenGL lerp? What's it called? I thought there was one. Mix sounds good. Mix. I don't like that reference. You have to make sure you're on the right page. Mix should be supported in all versions, and yeah, I think we're fine. Mix. So we're going to mix 0, 3 with 1, 0 and the dot value. So we range from 0 to 3 to the 1 there. And let's make this come from slightly more overhead. Make it come slightly more on the Y direction. This is why I normalize it, so I don't have to worry about having the right value, because the dot trick here only works if it's normalized. If it's not normalized, this doesn't actually give the right intensity. But since we don't care about the actual intensity anyways, alright, it's coming a bit from more overhead. You can see it's down there in the dot. But maybe we should just increase the intensity overall. What should the intensity be? If we bump the whole thing up and we can over-intensify it. Though I'm surprised there's not... Maybe our colors are just dark, yeah? You see there is a little tiny light spot there. I'd like to have it coming even more from overhead, because we have mainly overhead things. And I think the range is probably still too much. We don't want it to be ridiculous like that. So there's some shading here. He looks like he's over-segmentized though, right? And this is because of the way we're doing the segmenting now. There's too many segments here. And he looks like he has more segments than he does because it doesn't blend together, because our norms now don't take into account the fact that the segments are stuck together. And that would require us to know how far apart those segments actually are. I mean, the ones in the end, the tail segment should actually have, they should be coldly rounded, but the ones in the middle shouldn't be. And this is where it's going to become interesting in our code. How can we deal it so he actually looks like he's a connected worm? How should we do that? We have to know what side he's connected on. But it's already looking at least a little bit round, so that's good. We know it's a bit round. Let's at least do the dot that way too. We can give the dot, but we want a body segment. We want the dot to have something else. What should we do? What should we do? A bit more graphics, or yeah, let's just keep doing the graphics here. Let's try to get this thing looking like a worm. Let's get these segments connected. And this is going to get a bit more challenging now. How do we get these segments connected? Because it's all about this norm here. It's all about this norm right here. How much is pushed off? How much is actually done? And we don't have a normalized function yet. But if we just did this, you'd see it be connected more again, but it's not properly normalized. Plus it's the wrong direction. Okay. So we need to know the two sides he's coming from. Oops. So for each segment, you have a previous and a next segment. And this is more of a math saying which side is it on. So you have two angles saying where's the front angle and where's the back angle. We could actually do it this way. I'm going to say front angle is a float, back angle is a float. And how do we do this lerping here now? We want to say at the angles where he's connected, the vertex is still completely pointing forward. So we can do it really cheap now, really cheap. Let's do it, make a close angle function. this takes an angle float and b of a float. Angle closeness is always difficult because you could have multiple values going around the circle, and we're going to assume that these are always within a range. Assume 0 is less than or equal to a comma b is less than or equal to 1. No, it's less than or equal to 2 times pi. This makes this a lot easier to write. And what you can do now is you can simply do... The first easy check is... Our diff equals a minus b. Very simple. And we have to have an absolute value of that. Diff is less than, let's say, 0.0.1. I just do that for now. Then return true. This should probably actually more return of a continuous scale. Let's just return true or false. Now, if the diff is less than 1, but we have to deal with the case or diff is greater than 2 times pi minus 0.1, then return true as well. And return false. Close angle. So now you do here close angle, angle comma front angle, or close angle, angle comma back angle. We give this value, otherwise we give another value, otherwise we give the same values before. 0, 0, 1. This is still going to... Math does not contain absolute. Oh. Well, that's interesting. Does our math library not contain an absolute? Yeah, that could be challenging then. All right, so we're going to have to create a math absolute library. Man absolute. It's part of the C library, I guess. Nice selection there. You know, if you look for man abs, I'm not surprised by the pictures I'm getting, to be honest, but I just never think about this. I mean, man to me is like the old man pages on Linux. And so this has got to be the biggest contrast in results I've ever seen in a search engine, is that man abs gives pictures of muscles, but the first result is the man page. Now think about the guy out there actually looking for like abdomens and getting like this compute absolute value of integer. He's going to be totally confused as to what the hell is it doing here. He's going to write to DuckDuckGo and say, look, guys, your search engine is rubbish. I mean, like, look at this. What do you give me this man function, this function here for? What is this? And, oh, but now we need fabs. Oh, what does fabs give us then? Nothing. So we don't get any more pictures of abs if we're looking for fabs. So let's use fabs. We need fabs. And this is incidentally why I don't overload these for all of these yet. It's a pain in the ass. The full library will eventually have them, but I just import them for one type because it's the easiest to import right now, and I don't want to write all of them, but this is part of the standard library, so we're going to have to do it eventually. mabs is ABI double and ABI double raw no throw. I better check if this is actually the double though. Yeah. So you notice it's fabs is a double, fabs f is double, fabs. Now, when you see functions like this, this is one of the reasons why your language should support overloading, because it's a real pain in the ass if you have to remember all these little bits and pieces. So now we're going to export fabs, or abs. Let's export some abs. Export a six-pack. Come on. Abs. And when you take a float, turn a float. Again, in Leaf, floats are the default double type because single precision float is usually not what you want. So I've erred on the side of saying, look, if you just type float into your code, you most likely want double precision or whatever the system considers a native precision. As we go in the future, this will just increase to like more Some machines also have high precision. I'm kind of debating a leaf now whether high precision on x86 means the 80-bit registers, which nobody uses, are kind of garbage now. More than likely it'll end up being the 128-bit SSC registers. Okay, so we did a standard library. Now we have to recompile it. So dis/build standard library. Good. So now we should have an absolute function in the library. Unknown symbol pi. Okay, we gotta add that. Must have called it in the wrong place. Pi 2 times math.pi. Alright, what do we have now? Mismatch 248. Oh. That's in a weird line. Source type, I think it has the wrong line, doesn't it? No. Oh yeah, no, that's correct. We forgot to add the extra angles. Let's just put 0 and math.pi, and we'll just see how that works for now. And we'll figure out what the angles are later. And so it's always the one direction you can see. The two top. Although 0 should have matched. Alright, so we have something weird with that. 0 should have been this angle here and 1 on the other side. Let's just crash this. So 0 angle is here and 1 angle is here, and it seems to have did something different for both of them. And oh, I did this thing wrong. I have the wrong order here. Alright, let's just do it this way. var a norm is just going to be equal to this. And var b norm is going to be our normal norm. Okay, and if we're on those two angles, we want to use the b norm. Otherwise, we want to use the a norm. And I did something wrong. Switch no unifying types. Ah, yeah, that's because I split these off here. They have different ones. You can solve that by making constants always a literal, and then it should unify correctly. But again, this is probably the wrong type here, because this is also now the wrong type, right? You have to be very careful when you split these off, and because you can't call this one a literal, because it has non-literal values in it. So you can't do that. So let's just call this one a GL float 3. And we'll do the same thing here, just force the types on it. Alright, give me 2 minutes. There's somebody who keeps ringing at my door, and I have to figure out who that is. I'll be just back in half a second. Alright, sorry about that. I'm back. Children, they ring doorbells. So you force these two, and that should be enough then. And we still have something weird with the angle. But yeah, we have the two sides. And you can see when we go to a straight line, we kind of have what we want. We have that one brightness connected, and we're trying to get the two angles in. And now we have to figure out which angles do we want. And the close angle thing should probably be instead not close angle, but let's make it more like a range. So we can do a merge in these things instead. We can do a morph on this stuff instead. So instead of close angle, we want to do an angle offset. angle, I don't know what it's called. Angle offset equals a float, b float. I'm just going to return a value from 0 to 1. Maybe it should just basically be the dot product, to be honest. The dot product might be well enough here. Dot angle. So I'm thinking that's what we actually have. But I don't want to convert to an angle here, so let's just say, how would that actually work? So basically at 90 degrees, 1 when equal, 0 at 90. So this is basically a dot product, basically dot product like. And we're going to do the same thing. It's maybe I should actually convert to a dot product, and that would make the most sense, and that'd be the simplest. Efficiency-wise, do we have to care? We don't care about that, but do we really want that, or do we really just want to say within the range, and then we can control it? Because I might want to actually control it. Just do this. And so the diff is going to be this, and we have to convert the diff now. Now, if the diff is greater than if the diff is greater than 180, then the diff equals not 180 math.pi angle. Then def equals 2 times math.pi minus diff. So it just switches the two things around. Okay. So now all we want to do now is we want to clamp it in the range. We want to return clamp diff divided by math.pi divided by 2. This is a range of 0. So the bigger the difference is, the higher this value is, but I want to do the inverse direction of this. 0, 1, and 1 minus this. At the same time, I'm going to make a lerp function. And I'll just make it work on float 3s first now. GL float 3. T is going to be a float. And we can simply return b.x minus b.r minus a.r times t plus a.r. Once the language evolves a bit more, we should have clearer ways of doing this stuff, but this also isn't terrible. One way or another, you actually have to write these functions. So we have an angle offset, and where were we using this again? Angle. And var angle off equals angle offsets. Let's just say AO. Angle offset angle, comma front angle. We have to do the back angle as well. What does it mean? That means angle offset's a bad name. I'm just thinking about it. Because 1 is the max. Yeah, just do this. Avoid the thing. So it's an angle offset. Angle offset, and this is going to be a max of 2. We don't have a max function yet, so let's just write one. Okay, we have to write a max function. We're going to have to move these all to the standard library at some point. Line max And this one can also be of type T. We don't care what type it is yet. We don't even actually have to worry about this here, what type we're returning. You can actually use the built-in function a comma b like this in Leaf and just let it tune the types, and then simply say a is less than b, return a is less than b, then b, otherwise a. And this is enough to interpret all of its types. You have to care about when you're using floats and integers and stuff, though, that these can sometimes get annoying, because when you have this, there's a type balancing issue that doesn't know that these are the same types. And that's why if you force it to param t like we did up here, it can often work a lot better because it knows that these are all the same types. So the moment it has the first type, it can force the conversion of the other types. Otherwise, you get into weird errors. But let's try it this way first. And so let's look for that max function. We have the max offset, but actually we want the minimum offset. I just have to write that. Stupid me. Minimum offset. Min AB. Min. So we have this offset, and now we want to do a lerp. And the lerp was, we're going to say lerp between minimum offset, so B norm and A norm AO. Now we have this error, and ah, shit. It's not telling us where the error is. Well, it is, but that's in the wrong place, so it's getting stuck somewhere else. Incomplete typing means it couldn't figure out the type of something. So let's just start commenting stuff out until we figure out where it is. Not there. Not there. Oh wait, it's a different line now. So this is one of the ones right here. If it can't find a different type, it's going to be very explicit. We're going to give it a float here. Alright, so we're going to get rid of that. Min. Let's see what you guys... Alright. Cannot do implicit conversion from float to GL float 3 as data would be lost. If you need a lossy conversion, consider using lossy. Now, I don't know if you can put a lossy on an entire tuple. No, I don't think so. 257. Which is unfortunate. Should lossy work on an entire tuple? What if I do an explicit type? See, there's some things in my compiler that ends up supporting that I'm not actually clear on it yet, why it supports it. Yeah, no, it's getting mad here, so we're going to have to reconvert this whole thing. And we can do a simple function, lossy GL float 3 equals, and we're going to take anything here. We don't care what we're going to get out. But what we're actually going to get out is a GL float 3. So this is also a parametric function, but it lets us do lossy v.r, lossy v.g, lossy v.b. I don't worry about the syntax too much. I go back through these things afterwards. I'm working in a compiler. We're going to go through all of these and make sure it looks the way we want afterwards. But right now we're trying to push forward, and this is with the game programming, to push forward so the language is actually functional, because that's actually very important in language development, that you can do stuff with it. Alright, so now we still have an error though. GL float 3. Right there. It's still not what I want. Something's wrong here. Tuple does not contain the symbol R. Really? Oh, because it may not actually have it that way. Right, because this tuple is unnamed. It doesn't say what's in it. So to make this fully lossy, instead of using the names, we're going to say offset 0, offset 1, and offset 2 in the tuple instead. So we don't refer to the name, refer to them by index. Then it really supports more. Okay. Something still kind of looks wrong though. It's getting closer though. Of course, we don't have the right angle, so we only have the 2 angles now, and I just want to get a long enough shot, a long enough worm, so we can look at it going across the screen. Let's see what happens when we run into ourselves this way, well, not in the view of ourselves. Okay. The idea is going to be that as you have the offset here, the norm is going to be the same on these angles here, so in the places where it connects going across here, you have the same colors. And it really does look like these are close to the same colors. And let's make this a bit bigger. Yeah, you can see they're getting close to the same colors. They merge off, but we have to make them more dynamic, of course, because we want these ones here. So we have to figure out, I think the main thing is figure out which ones are actually connected, because right now we only do left and right, and we have to do it based on where the next and previous segment are. Where are those connections? Okay, now how do we do that? We can do a kind of cheating thing that we know. Segment point angle. We can give it 2 points. I point and a B and an I point. I think we have these here, I point. Assuming segments are beside each other. This makes this relatively easy because you can simply say that b.x is greater than, ignoring the wraparound. The wraparound is going to be a real issue, but let's get it working first without wraparound. If b.x is greater than a.x, then you can return 0, assuming from A to B, from A to B, from A to B. b.x is less than a.x, then return math.pi because it's going the other direction. b.y is greater than a.y, so it's a higher one, then return math.pi by 2. And I've forgotten where my base of the coordinate system is, so this one might be backwards. Because this depends on whether we have the top left or bottom left, and I'm pretty sure we have the bottom. So let's say math minus, or 3 times math pi times 2. Otherwise, we return math.pi divided by 2. Segment point angle. So what do we have here on all these segment angles here? I'll worry about the end segments afterwards. So previous body equals state.body.get 0. We'll assume there's always one there. And instead of passing the previous body, we're just going to pass in the previous body instead and let the function deal with it. Previous body. This is going to become optional at some point because we had to deal with one there not being there. Previous body, and we need next body, of course, too. So this doesn't really work. This doesn't really work. Doesn't really work. Okay, so let's go over to I point. We have an I point here. Now we have a vector. So the vector is going to be the thing. We have a collections vector. Let's modify our collections to have a function that has an optional get. Something I'm getting used to from the Rust programming, to actually have functions that can give different... Did I actually... And these should have, the standard libraries should have test cases, but we don't. So we have a get. Where's our get function? Get. We're going to make a section function called, I don't know what to call it. Get if valid. Index integer. And this is going to return an optional t. It may not be set. And it's very much like the first one, except if index is greater or equal to 0 and index is less than size, and then return, and otherwise we'll just return the default. And the default is going to be an unset optional. So we have a get if valid now. We're going to have to recompile those libraries. Okay. Recompilation of the standard library doesn't take long because there's not much there. And so now what we can do is we can do the previous one. We can simply do this. We can do state.body.getIfValid I-1. And this is one of the very clear reasons why I use integers and not unsigned values for indexes. To make such like this easy, I still consider it an error to use unsigned values for indexes. They just get you into trouble in a lot of cases. I+1, and that's the next one. And body segment, head position, head position. This is a bit weird. Where should the head be? I don't have a way to specify an optional none right now. To do. Optional, a none keyword, perhaps. And that'll be unset, and so the front, let's just ignore the front for now, let's do none none. It has no other body segments. So we can get rid of these two angles. Now instead of the angles we have a previous segment is an optional I point. And a next segment is also an optional I point. And what are those two angles that we have? We had to take care of these angles, and this is where it gets really sort of iffy how we do this. I want to deal with these angles, but because they're optional, yuck, how do we do that? We're going to have an optional float right here. Opt-prev angle is an optional float. We want to do has previous segments, so we can say has previous segments, then we're going to set this one then. Opt-prev angle equals, and I've forgotten what the functions we want. What we called it? We called it segment point angle. Segment point angle from the previous to the next one. From previous segment, or we get the optional of it, previous segments. And this syntax with optionals has to be improved a bit. I kind of like the Rust one with the if-let stuff, or the unwrap or and all that. And I'll probably inherit some of that stuff for optionals. Not all of it, but some of the stuff I like. To position. Same with opt next angle. So still optional. has next segment, then opt next angle equals segment point angle from position to the get optional of the next segment. So these are optional angles, front and back. So we have to deal with these angles down here. We can do the same thing here. We're going to start with an AO, a float of the minimum should be 1. Right? We have no previous one. So we're going to say has, what I call those stupid things, a prev angle, then AO equals the minimum of AO angle offset angle comma get opt previous angle. And we do the same thing for opt next angle, and we hope that this actually works. We do the offset, and I have a compilation, I have a syntax error, but then, I always forget then. Instead of if, I have then because it matches better with else. Wow, cool! I got an actual compiler error. Those are getting uncommon, but this is an actual compiler error. That's fun. Let's figure out where that is. You probably have a workaround. Wow, 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 wow. Fun. Actual compilation error. Where's it coming from? Bit before that point, apparently. If I don't push anything onto here, I can get rid of that. Don't push anything on. Oh my, what's causing the actual error now? Let's get rid of this whole function. Oh, it's not in that function. Where is it then? The other stuff hasn't changed. Let's get rid of all of this then. It's hard to debug a compiler. Oh my goodness. What have we actually done here? This might be from the actual X collections. Might have created an error here. Let's find out. Yes, the error's from there. So we don't have the get if val. The get if val is causing something weird to happen. So what's wrong with get if valid? Get if valid this is interesting. So something's screwed up here. Why is this getting us something wrong? I don't think it's not my leaf code that's wrong. I think it's clearly the compiler wrong at this point here, that it's not resolving this correctly. What if we just give it like this instead? And say var r is an optional t, then r equals this, return r. I know what it is. T here. We have to be very careful about this here. T can be anything. T could already be an optional. And so it's going to double apply an optional. It's going to return shared. So what I don't have is I don't have a way of saying, hey, there's not a type here. I can cheat knowing that there's no shared in here. What type classes do I have? I have functions that clean up the type, base type. They have a base type which cleans it up. I could do it this way. Oh, but I won't know what it is. All right, so I have an error here in the compiler. I'm not clear how to fix it. To do failed. And what else do we have that failed? Let's just do this whole thing failed. And we have another one that failed. The other version that we actually wanted is to actually return an optional T, but we have to be very careful about that because the T could already have optionals in it. And I'm not clear how to do that now. I'm really going to have to look at this a bit clearer, because this type of stuff should work. And how can I that simplified the logic down here a lot. Right, because we just say get if valid, and we return the next in the previous one, and we have an optional value of T then. What we could do is we could actually change the function here get default, but we don't want a default. We want an actual unset value. This has got to work a lot better. Get default has to accept optionals, get or none. Well, we can write it in the other code as well. We can write it over in the other code. Get if valid. And we can put one right here. We can do a get body if valid. And give it an integer here. X is an integer. X is less than 0. We can actually make this one return an optional I point. So we just write it out of line with a fixed name, and the fixed type here should work. Body if valid X is less than 0. X is greater than or equal to 0. And X is less than state.body.getSize, then return state.body.getX. And so we can get body if valid, get body if valid instead here. Alright, now it's hard to say if that doesn't work. We should probably make this longer by default. Now you can notice that the coloring changes as it goes around the corner. which is kind of what we want, but there's something still a little bit weird here. The difference is still a lot more than I expected. Like, I clearly want to have the colors in the middle looking the same. There is that body, but the up and down are clearly wrong. It's really, we're going down. It's clearly wrong. But going up, shouldn't really make a difference now, should it? Okay, now I need to think about this, how this is supposed to work. How can we simplify this so we can see it better? Let's start with a longer worm to begin with. Let's go to the game itself. Let's get a bigger worm body length. Let's start them at 10 so we can see this. And we're going to make the game a lot smaller, just so we can see it for a bit. Then we have a lot bigger worms by default. And we can also increase it. Let's increase the actual main size as well. Main. I can probably push it all the way to 1200 by 800. So now we have a much bigger worm, so we can see the issue a lot better here. And we can clearly see where it's the connection's there, but we don't have the right color. Alright, and where's the color here? So we have the color. The connection color should be the same, but there's this hard line here. And going up, it actually seems okay, almost. Going across is kind of wrong. So I must have the angles wrong somehow. Like this one at the bottom would be okay. It's clearly a different color, but it's almost correct. But they're still stronger than it should be. And that may be because it's just really the center color that's the same. The moment you get halfway, it has a different color. But I think we could live with this for now. But it's this one here, it's totally different color, which is totally wrong. And we're going to figure that out. Where is that? That's in the game render again, of course. This will probably be all I figure out today. And we get the previous segment and the next segment. That should be okay. The head we forget about. We don't have them yet. Segment point angle. And the minimum offset. And so B norm is the one where that segment is pointing directly at the camera, and that's supposed to have where we have a segment. And so AO says by default we have 1, which means takes the A norm instead, which takes the normal offset, so it's actually the rounded part. And we take the minimum of the angles. Angle offsets return the minimum, so we have angle and get previous op angle here, next angle. And that gives us the minimum offset we have, and we're just doing then we're doing a lerp on that. Let's just make sure our lerp's working by doing 0. Lerp's working fine, I guess. And let's do a lerp of 1, and that'll give us the complete side angle. And this makes them all a solid color as well. It might be because some are getting brighter that we don't see the problem. Alright, so I think AO is working. That's giving me a range there. So the lerp is working, loss is working, a get angle here is perhaps not working. Let's just output a whole bunch of these and find out. This is going to be a ridiculous amount of output. AO, let's do it here. Gotta put some lines in between spaces. Angle, previous angle. Let's make sure this is correct in all these cases. And let's also output the result. So they're all going across, so they should all have the exact same. Alright, and we have an AO. Yeah, this is so many segments though. But we have the op previous angle is the one that should be consistent. The op previous angle is, which value is the third value here? 0, 0, 0. And that appears to be backwards. Or not what we expected. Because the previous and angle, all of them should have been... What are we calculating? Okay, this is the, we need to know the angle from, not from here to this one. We really want these reversed. What is segment point calculating? Segment point angle. From A to B, and we actually want the other way around in ours. Because we need to know in our current dot what is the relative angle. Relative to our current position, what do we have? That looks like it might be better already. And that's 0 because we're going that way, so the segment was that way. And so if I go right, it should be 1. Or the angle should be 3, that's correct, should be 3. That's looking correct that way. Doesn't look like it has the right damn color, but it has like the right angle. Should really write test cases. We should really have a test library. That would really help, having a test library. This should also be positioned to the next segment. I'm being silly. They should be the exact same. That looks more like the colors are getting closer together. The head's still wrong, but the other stuff is actually looking like it's getting closer to being connected. There's still a bit of a line, but I think we actually have the right values now. So this looks like it connects right in the middle. You can see it has the same color, and it fades off fairly fast, though. We might want to say, hey, look, don't fade off quite so fast. We can get rid of this print here. I mean, it's still working with this print. This is printing an unbelievable amount of stuff, and Leaf is not efficient by any means yet, but that should be okay. And what we can do here is we can actually do a power of this. I believe we implemented a math power. Math, basic. We didn't implement the power yet. Ooh, let's see what happens if I type man-pow into the search engine. Aw, we don't get any funny images. Okay, what images does man-pow give us? Man-pow. Okay, some of those are not safe for work, but let's go on. Power functions. Pow, man-pow, man-pow, man-pow. Yeah, let's do pow, pow, pow. Pow. M-pow. Oh, this is just so I can reduce the extremity of that difference there. I want to have the AO not applied nearly as much. Pow equals X float. Float. Oh, this probably takes two values. Oh, I've having a hard time typing base and exponent float. Return m-pow b comma x. Yep. So what we can do here now is we can say math.pow AO, and we can take the square root of it. So it reduces it. So as it gets closer to 1, actually, no, I want the closer value, so I actually want to square this. Or even cube it to get it closer. Doesn't have pow, got to build the pow. I forgot to import pow correctly. It takes two doubles. ABI double. So now those are much clearer connected. Going vertical, we still have an issue, but those are getting much clearer connected. I'm happier with that now. We still have that issue on the head. The head needs to have a previous segment, so let's add that still. We have it the exact length of the board. Interesting. And this is what we want here. As you can see where it's clearly disconnected, but here should be the same color, and it still deviates quite a bit. And I think on the corners we might have something wrong, but I think it's the corners because this one's so extreme, so extremely pointing in a different direction that it doesn't quite blend. And I don't know how to deal with that. Maybe that should be okay. Okay, and the renderer. Let's go back to the game for a second, and no, let's go back to the renderer. We know there has to be one here. State.body.get state.body.get size -1. So this at least fixes the head situation. The head will have a previous one now. Invalid index, except if there is none there. Fine. Get body if valid. There actually could technically not be one, so that's quite correct. I'm not sure why it's changing like that. Maybe it doesn't. You know what? The head's not part of the thing. Is that part of the issue? I think maybe that's the issue, is the head's not part of the snake. Let's make it part of the snake. I think that's important. I think the game is incorrect that the head should immediately become part of the snake. And that'll break that off right away. And check collision. Oh, that's why we had it. We kept the head separate just because for the collision. And we had this fine. Maybe fine shouldn't be used. We have to exclude collision right now. Well, let's just get rid of collision for now. To do fix. They just won't collide. And we're drawing the head twice now, which is not what we want. So we still have the angles wrong on the corners somehow, and I think it's the up-down being wrong. Let's go right up here. I think I got that actually wrong when I said 3 times, and this should be 3 times. I think I got the Y inversion incorrect. No, it's still not making a difference. The hell? Like, it's got the one corner correct, but not the other ones. Test cases. Really need test cases. You know what we should do too is we should write a pause function in. Let's put the spacebar for a pause. Key sim equals edA-qa space. I don't think I have that set up yet. And then we'll say pause equals not pause. Or pause equals false. If not pause, or not pause then, sorry I keep getting that wrong. It's not pause, then we elapse, otherwise we do that. We have to go to the STL library and put the STL, do I have a key event? STL event. Literal edA-qa space, and rather than load this from the file, because they have some weird stuff in the way they create these constants, we're going to do a key edA-qa space g++ dash o/temp/stl. Which directory is this in? Alright, so space is 20. So this program does, this is a C program, this looks at the header files and pulls it out. And this is because it's too hard by hand to figure out what some of these keystrokes actually have. There are programs that will do this for us, we just haven't set it up yet. And this is just 0x20. So let's see if we can pause the game now. No, pausing isn't working. Let's make sure it's actually printing something. Standard.print line. Pause. I don't know if we can print booleans out. Well, this is weird. It sometimes works and sometimes doesn't. So we don't always get the keystroke. But we always get the other ones. There's something fishy there. Pause, not pause. If not pause, then we take the ticks, current ticks minus last ticks. Well, elapsed ticks is greater than 150. State the step elapsed ticks minus 50. Last ticks equals turn ticks. Why is a space key now? Now we're into an SDL problem. So control space works. That's like the weirdest thing. What do we have here? That's like really wacky. edA-qa space. Space is literally the ASCII character. Why am I not getting it then? I'm switching on key sim. And we don't always get the space character, so we have something weird in SDL right now. What other character do we have? Do we have a pause character? edA-qa pause? Let's try that one. Something wrong here. Pause is a really big number. That makes more sense. Something wrong. So the pause button works fine. So I don't know what's happening with the space bar. We're going to have to figure that out later. That's an SDL mystery. So now I want to look at what's wrong. So our merging here works fine. Body segments. It looks like a continuous segment. Up and down, though, is a problem. So unpause this. Let's go up and down a bit more. And let me create a square. Okay, so it's something really wrong. We have this way. Up and down is just really just wrong. But these ones here, it shouldn't make a difference whether I have it wrong because it's the same on both sides. By that, what I mean is that if I had the top and bottom wrong, it would affect the corners, but on these segments here, it wouldn't because the angles either way would match. But let's check those angles carefully again. We have that in the game renderer. Oh, you know, you kind of need a pi divided by 2 here. That would be helpful. It's still not fixing the verticals, though. Horizontally, we're fine. And vertically, you can see it has the wrong positions. Because when we walk vertical like this, there should be no problem telling that these are different segments. So something is clearly wrong here. From A to B, if the x is greater, the A angle is at 0, because the 0 angle is pointing off to that side. If it's less than x, oh, come on, no, I screwed that up. I'm an idiot. Then it's, I got the, oh, I totally messed this up. Man, oh man. That's 3 times math. Oh man, that's messed. Okay, now we have what looks to be correct. Somebody should really remove that stupid title text. Alright, so now we have going vertically, they're joined. Going horizontally, they're joined, but you can still see the corner here is split off. And over here, we have shading down in these corners here. And it's quite extreme now because we're still producing kind of a cone. We're not producing more of a circle. This is more of a cone, but that's okay. And here we have the shading in the right side and here. So we have a proper connection with the head and everything. So this looks good. I think this is creating the correct worm connection. And we're going to underdo it again now. We're going to go back down to where we do the power 3 and put it back down to power 2. And because it's less extreme, we can actually reduce the size of the circles a tad bit more. Because it'll be very obvious that he's connected now. We can have more segmented lines because the connections are a bit stronger between those lines. That would be even better if we change the segments so that in the direction he's moving, to explain that we're not clamping here to a flat circle, that this was actually more round, and the sections where it can join would be flat. That would be a much nicer approach, but I'm just going to leave it for now. We're going to have to get on to other aspects of the game. Let's go back to the game first of all. We have a few things to fix here. We have to fix collide. First off, we want to make the size back to 30,20, so we have it bigger. And the body should always include the head. The collision, we can't do body find anymore because it's going to find the head position all the time. Or can we? What does body find actually return? Let's go back and look at the collections. What does find return? An optional integer. We can do that. We can do that. Has at. And then we're going to return at does not equal to body.getSize minus 1 because that's where the head is. Otherwise it will return false anyways. I think that takes care of collisions. Let's find out. I've got some sort of error here. line 79. Always fit the then. It's really weird. Where? Oh yeah, get opt. Sorry about that. Again, I would really like to have the Rust syntax here would be like this. All right, let's take. Yeah, so the Rust syntax would be here if let sum at equals, let's say q equals at, and it looks a bit more bulky, but I'd like to have something like that instead because I like to be automatically unpack this, and this would require pattern matching. And somehow this has at. This might just be some pattern matching instead. We say sum at. If we have sum at equals at. So I think the pattern matching in Rust has a lot of is one of its really nice features. Excepting for the reference stuff. If you get around the references, then the pattern matching is nice. And we'll just deal with the ugly syntax for now, though. Pattern matchings somehow. So now I should be able to collide with myself again. That's good. I should have waited a minute to restart the game. And we have a worm that's scored together. So even if you go beside each other, you can still sort of see where your sides of the worm are. He still moves in complete chunks at a time. That would be the next thing to do, but I think I've done enough with this for today. This was mainly GL work. I have some things to fix. But he does more look like a worm now. You know, you see these green long worms that eat one dot and they grow super long really fast. Let's check the Vertex Shader again to see what we're doing with that. Maybe this worm should be brighter as well. Maybe that's part of our issue, is the worm's really dark. Right, the worm's quite dark. And these older games tend to have brighter colors. It's a brighter color, because now we tend to subtract it quite often. Although, what we should do instead is you keep the darker color, and in the Fragment Shader, let's oversight. Let's let the sun intensity go all the way up to 1.3, and that'll create a bigger range on the color. Yeah, I like that better. So the range goes up, so we have the color, and then you have the shiny highlights on it. So you can clearly see that in the color ones. Like when I produce the corner one, you can see the shine to the corner. We clearly have it, and then we have a little squish down here. I mean, these other colors aren't so delightful. It gets dark really fast, and it's not perfect, but you know, without doing something more advanced. You can see on the front one where we don't have a table connect, it does scale it round. And these end ones clearly look round. It's when they connect and we flatten them out where they don't look as round. And I think that's about all we can do with that, though. We can try reducing the AO power. Just be 1.5 instead. Let's see what that looks like. Then he starts looking more cut up. Like the segments don't join as well, and that's the reason why we introduced those. The power there. So let's put the power back to 2. Let's look at the Fragment Shader. We can let it get even darker if we really want. Intensity down to 0.4. All the way up to 1.5. This will make an extremely difference. And that makes it even stronger difference. But that starts looking really kind of silly because we're expecting some kind of ambient light. And those are like half circles there. And I mean, maybe that's actually the correct way. This is just kind of ambient light anyways. And to do actual ambient light, what you should actually do is just say, well, screw it. Let's take the normal light intensity and just say 0.4 plus whatever the intensity is. And that would be more ambient light, right? And that still produces extreme contrast, though. Though weirdly, it's more than I expected. Let's go back to the other one. That's fine like that. Not much we can do to change this even more. Like, if you want to see the difference, if we made this completely overhead now, the light direction, like 3, 0, 0, 1, we won't see any of the shading at all. Oh, especially with a semicolon. So you see it's a flat shading, you can't tell which way the light's coming from in this situation. Does it make a difference if I put it negative? It should. I mean, darkness. Although it's kind of a neat effect. It's actually of all of them makes them combine the most, but let's go back to here. We could try that. Let's see what the light is. And this is like a very basic lighting effect. And this is really not what we want. This is like inverted underneath the thing if he's walking on glass. So let's put it back like that. Clearly coming from that upper right corner. And let's make it more upper again. But like even more vertical, because lights tends to be more vertical, less extreme than that. What it also gives us, it gives us something in the game to control, like, you know, parameter where the light position is. And again, this is just something really quick. The purpose here isn't to do awesome graphics. This purpose here is just to show that we can use Leaf to control GL and actually get the vertex shading correct and how we do these things. And I'm trying to think of what else we could possibly do here. Because the box is only used for one thing right now, we might as well make it more interesting and give it some vertexes as well. So this vertex norm, not very much up. Do we have a normalized function? No, but oh well. These should be normalized, but let's see what happens if we just say, what corners are these actually? So this would be -1, -1, and this would be 1, -1. This would be 1, 1, -1, 1. And this will make a crazy color for that dot. It's just going to match the light exactly. And it's still nicer than what we have. It's a little bit extreme. Right, you'd actually want to say, well, you know, it's because it's way over, it's not normalized. We could actually take care of that in the fragment shader and just say, hey, you know what? It's faster here than on the CPU. And that evens it out a little bit more. But in the game yourself, you may want to say, look, no, Z is still the dominant component, but let's put a little bit so it wraps slightly in those directions, so it's slightly folded dot. Gives it a bit of a texture, but as long as we don't have a shape to it, the curve isn't going to make any sense. So we don't know what to do with the box, but that's just enough for that. So let's go back there and just, and if you want to see how extreme it can really get, let's just say, well, no, let's just make it ridiculous, and that the middle should going to end up being dark here. And that's a cone now, so that's a perfect cone, and that's the shading of the cone. And without the cone shape, though, it looks a bit funny. And the cone shape would be on the other one, so let's put that back to 1, 1, 1, 1. That all worked. Now I'm also going to go back to the worm here, and let's increase his steps so he looks a bit rounder. It's a ridiculous number of triangles for a worm now. So he's even more round now in the sections. He still has flat parts, but the other parts are less fragmented. So that means each section of the worm has 32 triangles, which is ridiculous for this type of game. And so every time we grow, it's going to have a lot more than that. But again, our engines, our GPL machines, they don't have an issue with this. They have no problem with this level of triangles. We have models that have millions of triangles on them. An old game like the old 3D games, like in the PlayStation 1 and stuff, we're probably at the point where we're already exceeding the capacity of their engine with this stupid little worm. they would have characters rendered with like 200 triangles, and that would be a decent looking character, like I think the original Tomb Raider games and stuff. And now we have this worm which is 50 segments long and 32 segments each. This stupid worm already has nearly 2,000 triangles in it, and it's absolutely ridiculous for a worm, but it's really not challenging our GPU. But it makes the game easier to play because it's easier to tell where you are when you're close together. And you can see when you're right beside each other, you can clearly tell that your worms are not connected at that point. We could also make them just a tad bit smaller than the square. That would also work. But let's move on for next time. I'll come back again and do some more tomorrow morning, I think. I'll announce on Twitter. Be sure to follow me on Twitter and follow me on Twitch as well. That's where I do the announcements for when I go live. I'm still a little bit chaotic in the timing I have, so it's better to watch for the announcements. I'm going to keep up, and this will be on Saturdays. I do Wormies for now in Leaf, and I'll try to get stuff done on Leaf itself in between, so that every time we come back I have more progress. But I think we're far enough in the language that we can actually keep writing an actual game out of this. And so next time what I'd like to do is maybe make a title screen. I might decide to do a title screen, or do I want to fight with gamepad control? Or actually, let's make the game more interesting. Let's actually extend the game. Let's make a second dot that moves around the screen. So we have a second dot then that moves around the screen, and that will be what we could do for the next segment. Make another dot that we have to chase around, and also make this dot never end up inside the worm, which it does sometimes. Doesn't end up often because it recovers so little of the board. It rarely does, so we might not have to worry about it. And then we have to decide, maybe we should add blocks to the board. That's another option. Just obstacles where stuff can't appear, and then it's important that the block, oh, I died there. Good. Then it's important the food doesn't appear there. But I hope you're enjoying the show. Just let me know what you like and don't like, and I'll always post this up to YouTube as well. But if you want to watch live, feel free, and you can chat, then you can ask questions. I know there's not really much to chat sometimes, but as we progress, it might be a bit more interesting. And let other people know about the show. And I enjoy doing it. Tonight, if you want to watch me do the competition with Rust again, I'll be doing the Code Royale again, which is more of a desktop defense type automated bot programming, and that'll be in Rust, and you'll see where I get some of the ideas from. But thank you very much for watching. Subscribe, retweet, and all that great stuff, and thank you very much.